Ladies and gentlemen, please welcome to the stage Corporate Vice President of Azure Data, Rohan Kumar.
Well, good afternoon and welcome everyone. First of all, thank you so much for being here with me today. We have a jam-packed session filled with exciting announcements and demos aimed at making data professionals like you very productive, no matter where your data lives. And my hope is by the end of the session, you walk away with three things. You get to learn about our continued mission to expand the capabilities and use cases for SQL Server. Our revolutionary vision around hybrid, which enables you to take Azure Data Services anywhere. And finally, the work we are doing to make data professionals, make it really easy for data professionals to gain significant value out of our operational databases and analytic platforms. But before we get started, I want to take a moment to sincerely thank you for your energy and engagement with the Azure Data Platform. The applications you're building on Azure are truly inspiring to me. You all are truly living the Azure tagline of inventing with purpose. The work you're doing for your companies to digitally transform is helping you better engage with your customers. It is helping you build better products based on the feedback that you're receiving both from your internal customers and your external customers. You're helping your companies become a lot more data-driven by providing your employees the tools they need to do their best job. And finally, you're finding out unprecedented ways to save costs using operational efficiencies. So it's fantastic. Let's get started. You know, one of the questions I always get asked is what's Azure Data and Azure's point of view, on how are we differentiated? And this slide tries to capture that. You know, the first aspect really is about limitless scale. If you look at the work we have done just around our operational databases with Hyperscale, and what we announced today on our analytic platforms by bringing together data warehousing, data integration, and big data analytics at petabyte scale, it's really about preparing for the future. AI, both in our own systems and services, is built in by default. We're essentially making it really easy for you to build intelligent applications and intelligent workloads on the data services in Azure and SQL Server. Hybrid, this is really about choice, operational freedom that we want our customers to have when they go to deploy cloud-based solutions, including the business model. So really, you should be able to gain insights from your data no matter where your data lives. That's a key promise of hybrid computing. And finally, security, compliance, governance is becoming very, very critical with the rise of GDPR and similar regulation, CCP, et cetera, that's coming out. It's only going to increase and spread in the world. So there's a huge focus that we've had. This has sort of been very much in the DNA of us as being an enterprise company, is the focus on security. Now, moving forward, really, it's phenomenal to see the journey SQL Server has taken. There's been innovation over the last 25 years, and SQL Server just keeps getting better. Let's take a look. All the way from edge to the cloud, you have some version of the SQL engine that's running. Of course, you have your SQL Server that runs in your own data centers, on bare metal machines, on VMs. We've gotten SQL Server to work really well in a containerized environment. On the public cloud side in Azure, we have the Azure SQL Database Service, which supports both a very easy way for you to migrate your existing applications and workloads into the cloud and save costs. We have a very modern serverless architecture for you to build new applications. Now, all the way back to the edge, did you know that SQL Server, actually the core database engine, runs on ARM devices on the edge with a very, very low footprint of 300 megabytes? Now, why is this important, you may ask? Well, if you look at the expansion of data, the volume that at the rate at which it's growing, we believe 70% of all data is going to remain on the edge devices because of the proximity that you need to make real-time decisions. So the investments we've made in SQL Server around built-in AI, where you can sort of build models and score against those machine learning models, now can run on ARM devices. So it's everywhere from edge, your private data centers, virtual machines, containers, public cloud. It runs on the choice of your platform, whether it's ARM, x64. You have the choice of your language, of course, not just .NET, but look at all the open source languages, Java, Node, Spark, R, Python, everything works with SQL. It's really fantastic. Looking at the momentum for a second, there are more than 5 million instances of managed SQL running in Azure. The serverless option that we released a few months ago It's just been fantastic to see the rise in the adoption. We have over 3,000 customers who are using Azure SQL in a serverless model, which essentially means you just issue queries. You never need to provision the instance or the database. It just works. The other thing that I'm really excited to see is the adoption of SQL Server 2019. You know, every time we do a release, we believe, well, we never outpace the rate at which this preview has been adopted. But again, SQL Server 2019, over 50% higher adoption when you sort of benchmark it against the SQL 17 as an example at the same time. It's really, really phenomenal to see. Now with that, some of you may have heard this in Jason's keynote, but I'm super excited to announce the general availability of SQL Server 2019. How many of you are excited about it? That's fantastic to see. Now, sort of getting into the details of what's there in SQL 19, there's a lot of stuff that's packed. Before I get to the main focus areas, if you just look at the performance and scalability investments we've done, we just recently, just yesterday, the #1 benchmark on 30 terabytes TPCH by Cisco and Microsoft was published. SQL Server 2019 is #1 in the world. That's fantastic. The work we are just doing around security, we released this feature called Always Encrypted back in 2016. We are taking a significant next step in confidential computing with what we release, the features we are releasing with SQL Server 2019. It's a game changer. And there's a lot of work that we've done with Microsoft Research to make this possible. The work we are doing just around availability. Now, this is an example of how we've learned from the cloud. There's this feature called accelerated database recovery. How many of you have actually faced an unplanned failover that happens in SQL and the recovery takes a very long time? I'm sure several of you faced that. With accelerated database recovery, your recovery time reduces to maximum a few minutes. In the cloud, all our 5 million databases have this enabled, and we see even in case of unplanned failures when nodes go down, recovery happens within just seconds. It's phenomenal. Now that sort of brings me to the key focus areas. Big data clusters. With the release of big data clusters, SQL Server essentially can manage your entire data estate. It is truly a unified analytics platform on premises, just with this release. And the native integration we have done, not just at the core storage engine and the query processing layer, but the work we have done around Azure Data Studio to make it really seamless, to have that modern experience of notebooks to deploy, to monitor your big data clusters. So with HDFS and Apache Spark natively included is really, really groundbreaking. Right? And we've seen a ton of excitement from our customers who are looking at leveraging their existing skills on T-SQL, both manageability and development, to essentially extend that entire value, the years of investments they've made onto the big data platform. And then the work we've done around the data virtualization, which is a significant step forward in what was released as Polybase a couple of releases ago, where SQL Server can be the analytics hub for your data and can connect into systems like Oracle, Teradata, Mongo, Sybase, all kinds of open source databases, Teradata, Oracle, etc., which essentially means without moving the data, you essentially have built SQL Server 2019 as the hub. And there's a lot of intelligence built in how we cache, how we push down queries to make it really, really performant. So it's a phenomenal release, and can't wait to see how all of you find and use that. Now, one of the things we're seeing a huge traction on is migration to the cloud. SQL Server's migration to the cloud to just gain a lot of TCO benefits, just given what managed services give you. Things like high availability, disaster recovery, performance best practices, security best practices, classification of your data. A lot of high value is sort of there in managed services in Azure. Even on our virtual machine-based option, we basically have things like auto backup, auto patching, which give you a lot more than just regular VMs. And GigaOM sort of recently published some benchmarks by running the TPCE queries. And it's almost a no-brainer, and this wasn't a surprise to us, by the way, where on PaaS and both PaaS and virtual machine-based options, if you compare against Amazon, we are significantly much better when it comes to price and performance. So if you look at the capabilities we've added with things like managed instance and all the hyperscale serverless and the business model investments we've done for our most trusted and loyal customers, it's a no-brainer. If you're migrating your SQL Server to the cloud for whatever reason, Azure is your destination, hands down. Now, I'd like to invite David Schneider, who's the VP of Engineering of Systems Imagination, to help us understand how they've used the big data clusters investment that we've done in SQL Server 2019 to really change the game in the research that they're doing. David?
Thank you very much, Kumar. So at Systems Imagination, what we do is we try to find new oncological therapeutics. By a show of hands, how many people in here have had a family member or a friend and it's impacted you, from cancer? See, yeah, I've lost 2 family members to cancer very recently. So it's important to us, and everybody in this team picture that you'll see right here, young to old, this is part of our Tempe team, has had a family member impacted by cancer. It's a very complicated disease, and we're very passionate about what we do. But that complexity comes with data and scale. There's petabytes of data, and it's over 10,000 or actually tens of thousands of files. So before, when we had to do analyses, what we would do is we'd take those tens of thousands of files and we would format them in some way that we could probably absorb them into another system and then maybe use some type of ETL to get them into a database, and from there, harmonize the data, then extract some data that's scoring, and then take that and put it into some type of neural network or machine learning. With SQL Server 2019 big data clusters, we could do all of that in one system, and that was really groundbreaking. And so we said, maybe we can test a hypothesis that hasn't really been tested before at scale. And that hypothesis is around something called synthetic lethality. So in a normal cell here, we're going to do a brief biology lesson. We have 2 genes there that both perform DNA repair. In the cancer cell, a mutation in the BRCA gene there is preventing it from performing its job of DNA repair. The PARP gene, however, is still doing that job. So synthetic lethality takes advantage of this against the cancer itself by we inhibit the PARP gene from doing its job. Now neither gene can perform DNA repair. The cell is no longer viable. So this is a really great way to target cancer cells within a tissue. The challenge here, of course, is, as I said, the scale of data. There's roughly 22,000 protein coding genes in the body, so you're looking at hundreds of millions of data points with hundreds of features on each one. I'm going to show you a little bit how we had to harmonize that data and everything else. So the first thing is we have to make sure out of those tens of thousands of files that we're looking at the right file to harmonize. So one of the great things we can do is we can actually preview data here, and I'm just going to show you what that looks like. When we preview the data, we can actually look at the file inside, and remember, we're all here inside a big data cluster, and we're using Azure Data Studio to do this. So I can go, yeah, that's actually the NCBI file that I want to look at for genes. That's a really great thing. Now I don't have to question which file I'm pulling in to harmonize. I'm going to go ahead, for the sake of brevity, to start importing some more libraries so we can look at some things later. But now that I know that I wanted this file, I want to be able to pull it in. So what I would do is create an external table and then actually run SQL on it. Now, what I just did here is I actually took data that's sitting in HDFS and did something called data virtualization, so I can actually operate on that, merge it with other files in SQL Server in the SQL Server context. That means now I can do my harmonization in SQL Server, even though I haven't had to move those files in and out of SQL Server themselves. That's incredibly powerful and really helps us validate and move through our harmonization much faster. The next thing, and this is also really important, is in my little magic button here, we've again collapsed this for time constraints, I set up a Spark instance, and so this Spark instance is sitting in the big data cluster, so when I actually export data from the SQL Server, I'm not going to have to move it into a new compute instance. I can just grab the data directly from the SQL Server into the compute instance here. And here again, we can see there's another way actually to view the same data. So what we did is actually we looked at all gene coding pairs. That's the hundreds of millions of them. And what we did is actually analyze them against what would be a synthetic lethality. And we did that in under the 25 hours at a cost of less than $3,000. Now, I want to compare that to how long it took for us to do it, and we are experts at doing this locally. It took us several weeks and equipment that cost $80,000. So this was an incredible, unprecedented increase in both speed and efficiency of what we were doing. I encourage you, those of you that are interested in this work, we are published in the Journal of Clinical Oncology and also in the 2019 ASCO findings from this year. And I'm going to go through a couple other things here. I'm going to go through and set up and train our network model. And then we're going to go through at the end and kind of really hit the key points here, which this experiment did. And it's important that we recognize that this is just a subset of the data that we're looking at. So what we did, and what the neural network just did, is we actually took the output of all of that data directly from SQL Server in the Spark instance that's running on that big data cluster, and we scored it, and we have predictive scores out of there. So what the scientists would do from here is they would then look at this data, we would output it to a file, and I'll show you exactly how we do that. And then they would look at it, and they would actually look at it right here in Sandance. And so a scientist would look at probably the predictive score against the other scores. So now when we send this data out to the systems biologists and the molecular biologists and geneticists, they can look at this and start filtering it by score, look at the data and start understanding, well, which pathways, which biological processes, which molecular functions perhaps are impacting this the most. There's something more than that to this though. This is actually, each one of these is actually a data point, and that's very, very important because now somebody can actually look at this and say, oh, those two genes, I actually know one of those, I know why that would be targetable, and that's why that's really useful. So this data can now be filtered again, fed back in, and we can rerun the hypothesis. So SQL Server 2019 big data clusters allowed us to take petabytes of data in tens of thousands of files, look at it, make sure we're harmonizing it correctly, using data virtualization to actually look at the data inside SQL Server, harmonize the data in SQL Server using SQL, and then run a Spark compute engine on the output to generate this output, and then we could then from there to give it to the systems biologists. There's something else here that came out of this, and I think this is really important. Out of this experiment, we actually found 5 new novel synthetic gene pairs that have moved from here, this is called in silico testing, into the lab. That means that there's 5 new things that the lab can move on faster than otherwise happened. This took less than 23 hours. This is an acceleration of from weeks to 23 hours to put something into the lab to start testing on. I'm David Schneider. I'm with Systems Imagination and with SQL Server 2019 Big Data Clusters. We're helping accelerate cures to cancer. Thank you.
Thank you, David. And this entire system is running in production, correct? This whole system is already running in production and you're sort of using it,
This
right?
is, everything you just saw, this is live. This is our real system. The only thing we did is we cut the data down a lot because we wanted to run it in 6 minutes, not 23 hours.
Thank you, David. Thank you so much for sharing your story. It's fantastic to see what you achieved with SQL Server 2019 Big Data Clusters. Now moving on to operational databases. We have a whole span covering proprietary databases with SQL Server, open source databases, both on the relational side and on the non-relational side with Mongo and Cosmos DB and Cassandra on Cosmos DB. It's a pretty amazing service. And with Postgres, MySQL, and MariaDB, we actually have a complete spectrum for operational databases in Azure. And the momentum has been pretty amazing. If you look at the work we've sort of recently launched, 20,000 IOPS and 16 terabytes of memory on a single scaled up managed MySQL instance. It's phenomenal. We're seeing a ton of traction in the gaming industry. Today, I'm really excited to announce for our open source relational databases, that is Postgres, MySQL, and MariaDB, we are launching the reserved instance pricing options, which is going to make it really attractive to get your workloads and open source databases to Azure. As a principle, we are investing a lot in the community. With these open source databases, it's not just about getting them and innovating in Azure, but there's a ton of innovation that we're building and which we are contributing back to the community. If you look at the work we've done around making Azure Data Studio work with Postgres, there are tens of thousands of Postgres developers who are using it. The work we have done to essentially build the auto HA option for Postgres and contributing back to the community essentially is along these lines. On the multi-model NoSQL side, I'm really excited to announce that the Mongo API version 3.6 essentially is now generally available on Cosmos DB. And if you really are a MongoDB developer, the best MongoDB database in the world really is on Azure. It's the only one that supports multi-master as an example. It's a great momentum. Let's take a look at a few customer stories. With Cosmos DB, Coca-Cola and Walmart are making a huge bet in migrating their NoSQL database estate to Azure. When you look at the work we've done with HSBC, who's a huge customer of MySQL, and Chevron, who's a huge customer of PostgreSQL, and they're using our managed services in Azure. These are just a few examples, and you see a whole bunch of them on the slide, where there's just a ton of momentum being built around both the NoSQL open source and the relational open source options in Azure. Now, one of the things I'm really excited about is announcing the general availability of Azure Postgres Hyperscale. We announced the preview of this based on what we had with the Citus Data technology back at Build, and now the service, this option of running very, very large relational databases based on Progress in Azure is generally available. Perfect. And so to showcase the value that the technology that the Citus team built in terms of scaling out compute and storage to truly build a relational database that scales to hundreds of terabytes. Even internally at Microsoft, we have actually a petabyte scale Citus database that we use. It's a relational database, mind you. Please let me invite Claire Giordano on stage, who's one of our product leaders on the Postgres team. Claire?
Thank you, Rohan. So my name is Claire Giordano, and for the purposes of today's demo, I'm an enterprise software architect at Contoso Wind Farms. And one of the things I'm super obsessed with is getting real-time insights on the state of our windmills so that we can continue to operate them at peak performance. So before I log in to my sensor application, I want to talk a little bit about the database. So we run on Azure Postgres using Hyperscale, and first, I want to show you how easy it is to create a Hyperscale Citus cluster. So I'm on the Azure portal, and I'm going to provision a database, Postgres. And you can see on the right-hand side, there's a Hyperscale Citus deployment option now. And it's 100% Postgres. It's not a fork. And as I go to create this database and configure it, the first thing I'll do is set the number of nodes in the cluster. And I'm going to set it to 4. And I'm also going to set the number of vCores for each node to 16. And it usually takes just a few moments to create. And there we go. The deployment is complete. Voila, it is that simple. Now I want to pause right here and point out two things. With Hyperscale Citus, you can scale out not just storage, but also compute and memory. And as an enterprise architect, I did not have to make any changes in terms of re-architecting my application or changing the business logic in order to use Hyperscale. In fact, to my application, Hyperscale looks just like a single node database. All right, and here it is. So what I want to do now is I want to log in and show you a few things about my application. So we have over 14,000 windmills around the world. Each of them has multiple sensors on it, and they're all sending data back to us constantly. That means I'm ingesting over 100,000 sensor readings each second. And I have over 1 billion records in the database right now. Now, I can see that I have a latency warning, which I clearly need to investigate because delays in getting my reports and my information about the windmills could lead to downtime of the windmills and interfere with my ability to deliver power. And I have a sneaky suspicion that it has to do with the increase in the volume of transactions over the last week. So to investigate, I'm going to head over to Azure Data Studio. And first, let me show you a little information about the type of data in my database. So you can see that it's fairly standard sensor data, types of sensors, their geolocation, as well as the reading information. But the more interesting thing is to look at this query, which I know powers some key parts of my application. And I want to see how it's performing. And here are the results. The more interesting thing is to look at how long it took. And it took 2.5 seconds. Now, I know from working with this query that that's too long. It should be faster than that. And so I want to investigate this. And I am going to, let's see. After I've investigated, I've figured out that I need to increase the size of my cluster. And so I'm going to go ahead and configure it to add more nodes. Now remember, under the covers, what we've done with Hyperscale Citus is we've transformed Postgres into a distributed database. So I still have all the rich transactional support, JSON support, and all the Postgres features that I rely on. Now what I can do in increasing the size of the database is I can scale out all the way to 50 nodes, and I can increase the number of vCores per system to 64 vCores. And what that means, if you look on the right, 50 nodes, 64 vCores each, that's 3,200 cores in my database cluster. And I can scale out to hundreds of terabytes also. Thank you. So I don't need a cluster quite that big for this example. And so I'm going to scale down to 10 nodes at 16 vCores each, and that's what I'm going to save to. And it provisions, and there we go. I've got my 10-node cluster. And while I was adding nodes to the cluster, the data gets rebalanced between the old nodes and the new nodes with 0 downtime. So I can continue to ingest, all of my queries continue to run, my team stays up. It's a fully online rebalancing operation. All right, so at this point, I want to go back into Azure Data Studio and rerun that query that used to take 2.5 seconds. And let's see how it performs right now. Yes, it's less than a second. That's 2.5x of what it was before. And that's not a coincidence. Your query performance will scale linearly with the size of the Hyperscale cluster. All right, so let's go back and look at my sensor application, and sure enough, the latency warning is gone. And I think the thing I really want to point out is that I've also continued to ingest 9 million records while this was happening during the demo as I rebalanced and grew my cluster. The thing I'm most excited about with Hyperscale Citus is that I don't have to worry as an enterprise architect about how to scale my database anymore. Thank you very much, Rohan.
Really fantastic to see. Thank you. Now, please let me invite Danny Piangerli on stage, who's the Chief Enterprise Architect for Finastra, to come and share learnings using Hyperscale Postgres.
Thank you, Rohan.
So Danny, can you share a little bit about what you do at Finastra?
Sure. So Finastra is one of the world's largest fintechs. So we service financial institutions around the world, primarily through offering digital banking, lending, and payment applications. We also service, and this is something that I'm very excited about also, we serve those same financial institutions and other fintechs and even competitors on our brand new open banking platform, which runs on Azure services, and we call that fusionfabric.cloud.
That's fantastic to hear. So, why did you choose Azure and the managed Postgres service for your needs?
Well, so last year we acquired a wonderful digital banking company called Malauzai. With that acquisition came hundreds of customers, millions of end users, and a multi-terabyte relational Postgres database. As we looked at continuing to scale that database, growing business, we made many considerations, from continuing to throw hardware at the problem all the way over to re-architecting the solution. And that's when we discovered Hyperscale Citus. As Claire showed earlier, we were able to take the Hyperscale solution, and we're in the process of doing it, and continue to expand that load across those worker nodes. And the most important thing for the team is we didn't have to fundamentally change the application. So we still got to keep the application intact. The application still makes use of relational data structure, and we made minimal change, and we achieved maximum scale with that. Very important for us.
Perfect. Thank you so much for coming and sharing your experience, Danny.
Thank you.
It's really great to see you succeed with Postgres.
Great. Thank you.
Thank you. That's a real fantastic story. It's always a joy to hear customers come and talk about how they're succeeding with our data services in Azure. Now, moving on to Cosmos DB. This is the data service that's been designed from the ground up in a super differentiated manner. There are lots of data services that give you, guarantees on availability, but Cosmos DB is the first and the only data service across all clouds that gives you financially backed SLAs on throughput and latency as well. So as you see on the screen, there's just a ton of value, just the flexibility of writing new event-driven applications, serverless models. You're just seeing a ton of growth in that happening in Cosmos DB. It supports multiple APIs. It supports Mongo. It supports Cassandra. It supports Gremlin. And there's a whole bunch that we plan on bringing. And for each of these, it makes a fantastic ecosystem for the developers that are associated with these APIs. We are seeing a huge amount of growth in both the Mongo and the Cassandra ecosystems as an example. The performance and scalability, just given the true scaled out nature of the service, is just truly phenomenal. The global distribution aspects, where you're able to replicate your data really, really quickly just in multiple regions of the world, just enables you to build a certain kinds of workloads which is just not possible without that technical differentiation. And it has industry-leading SLAs, 5 nines, for both reads and with multi-master for write availability. Just given this strategically differentiated capabilities of Cosmos DB, in 2019's Forrester Big Data NoSQL Wave report, it got the highest scores for strategy and roadmap, and it was listed as a leader among all the other databases. One of the things I'm really excited to announce is the autopilot capability for Cosmos DB, which essentially allows the Cosmos DB containers to scale up and down along with the nature of the workload. So as a developer, you never really have to worry about provisioning the right number of RUs for Cosmos DB. The underlying system has machine learning-based logic that essentially helps it figure out based on your workload patterns. It's a phenomenal step forward towards developers who are using Cosmos DB. It's in preview, and if you've been using Cosmos DB or if you haven't, definitely try it out. It's really fantastic. So moving on to our hybrid story, as you saw this morning in Satya's keynote and hopefully in Jason's keynote as well, if you attended it, we've taken a huge step forward with our hybrid offerings. To begin with, we actually had both a software and hardware stack of Azure available in Azure Stack and significant amount of value in edge computing through Azure IoT. With Azure Arc, which was launched this morning, one of the key capabilities we brought in is the ability to run Azure Data Services, managed Azure Data Services, anywhere in the environment of your choice, as long as you essentially have a Kubernetes endpoint. Any Kubernetes endpoint, really. So if you want to run it on Amazon, you want to run it on Google, you want to run it on, of course, Azure, in your own private cloud environment, the only requirement is to just have a certified and a supported version of Kubernetes. That's it. So with that, I'm super excited to announce the availability of Azure Data Services as a part of the Azure Arc family. And we're starting off with SQL and Postgres Hyperscale, but our intention really here is to get, over the period of time, all the data services that we have in Azure to the Arc deployment environment. It's fantastic to see that. Now, outside of the fact that you have the flexibility of deploying these data services wherever you choose to, what other benefits do you get? The first thing is, when you look at the SQL's deployment option, only Azure Arc and the data services that come with it is the way you get an evergreen SQL, which you so far only got in Azure. Now you have the capability of getting the exact same capability in the environment of your choice. We basically essentially are getting the cloud billing model as well. If you essentially think about the model where the model that you have in Azure with respect to how you pay for the resources you use, you essentially basically get that capability in the environment of your choice. Unified management, unmatched security, all these great value propositions that we have in Azure for these managed data services, our intention essentially is to get all of that. Like I said, we're starting out with Postgres and SQL, but this essentially is going to come to all the data services. It's really, really exciting to see. Now, to actually showcase, we have customers like NTT Docomo and Zeiss who's bet heavily with us on a hybrid story. And we also have partners like HPE who are co-building solutions with us based on the work we are doing with Azure Arc. Let me play a video of Eric, who's the Vice President of HPE, to showcase his story.
Hello, my name is Eric Vogel, and I'm part of HPE's hybrid cloud services business. For the past 30 years, HPE and Microsoft have been partnering together to combine our strong portfolio of solutions and expertise to help solve customers' most demanding problems. Today, we are very excited to see Microsoft bringing Azure Data Services to run anywhere with Azure Arc, extending an industry-first data and analytics as a service experience with cloud-based management and the administration to the infrastructure. The ability to access the latest innovations from Azure, such as the evergreen Azure SQL Database Managed Instance, Hyperscale for PostgreSQL, and intelligence performance is simply amazing. Knowing a lot of our customers operate in hybrid environments, we are thrilled about the unified management capabilities from Azure Arc that truly deliver a seamless experience to manage both databases and the underlying infrastructure. Imagine that you can apply the same Azure policies and role-based access controls across both environments, and that you can even access Azure Security Center to protect all your data on-premise. Customers are still at the center of all technology. HPE GreenLake and Azure Data Services will deliver a true as-a-service experience to your apps and data, allowing you to meet your business needs with the benefits of the cloud experience. With the ability and transparency of Azure Arc on the underlying infrastructure, we believe it is an amazing opportunity to innovate on both the technology and the business model. We bring to life data and analytics as a service to our customers. We are excited and hope to see you all joining the early adopter preview. Thank you.
It's really fantastic to see, the Azure Arc and the data services, managed data services that come with it is a true game changer. One of the things, if you look at from the very beginning, Microsoft's been very clear about hybrid being a very core part of our strategy. We've had this since the very beginning of Azure, really. And today it was a significant step that we took of making it even more easy, even more flexible for you to run your solutions, existing solutions and new solutions in hybrid environments, effectively, commoditized around Kubernetes as the container environment. To actually showcase how Azure Arc and data services come together to solve customer problems, please let me invite Anna Hoffman, who's a data and applied scientist on the Azure Data team. Anna?
Thanks, Rohan. If you saw Erin earlier today, imagine Erin transferred her responsibilities to me, leaving me responsible for IT operations at Woodgrove Bank. Now, Woodgrove Bank has a heterogeneous environment with increasing system sprawl and data silos. This is my IT operations dashboard, and my job is to provide agility while maintaining compliance and security across the entire estate. So I'm rolling out a new risk management application, so let's see how easy Azure Arc can make deploying Azure Data Services to my data center. In the portal, I have options for Azure SQL DB Azure Arc and Azure Database for Postgres Hyperscale Azure Arc. If I select Azure SQL Database for my app, I can go through a familiar flow. Except for the Arc location, I can actually select that Orlando data center, which Erin deployed on stage with Satya earlier today. Now, what we're deploying is the same evergreen SQL that's only available in Azure. Now, provisioning SQL to your on-prem environment is a task that can sometimes take hours. But with Azure Arc, we can do it in a matter of seconds. Now, once this is deployed, we can start to access other Azure features. For example, I can enable things like advanced data security, and my risk management database on-prem can immediately start to benefit from things like vulnerability assessment scans and advanced threat protection alerts. So let's save this and go back to my dashboard. Now, in my Chicago environment, I can see that I already have a number of Azure Arc services enabled. I also see some reminders that there are some updates that are available. Updating and patching on-prem is something that requires constant diligence. Now, when you go to Azure, we can help you with that. And now, with Azure Arc, we can help you too. In the portal, I can enable automated patching and define my own maintenance window. And I can sleep well knowing I'll never miss a security patch again. Back in my dashboard, I see I have another alert. It looks like my PostgreSQL Hyperscale database is hitting a CPU limit. Provisioning extra servers and databases to meet unexpected spikes in demand is something that can be time-consuming, not to mention a little bit stressful. Now, since Azure Arc already knows the capacity of my data center, I can actually scale out on demand. Like Claire showed you earlier, I can scale PostgreSQL Hyperscale out to over 3,000 cores if I need it. Back in my dashboard, I can see that my cores is significantly increasing and my CPU issue has gone away. I can do the same based on capacity with Azure SQL Database, and I can also leverage things like read replicas. So with Azure Arc, Azure can now enable you to deploy, manage, and secure your data estate regardless of where that data lives. So we're bringing the power of Azure to anywhere you are. Thank you.
Thank you, Anna.
Thanks, Rohan.
So hopefully you got a little bit of a preview into how game-changing Azure Arc and the managed Azure Data Services that come with it is going to be. It's truly going to be transformational and a significant new step towards hybrid computing in the future. All right, moving on. The next thing really is around cloud analytics, and hopefully you got to see the announcement this morning, with Satya and Jason's keynotes around Synapse. It's a significant step we've taken towards really deeply integrating SQL data warehouse, data integration capabilities, and big data analytics into a single unified service. And one of the key reasons we did this is to significantly reduce friction and time it takes to create these complex analytics pipelines. In most cases, you should be able to get started with just a no-code experience. Really, that's our goal really is to significantly reduce the amount of time it takes just to get started, given the expectations that every business has around getting their time to insights reduced. So with Synapse, Limitless scale, as I sort of spoke about, we are designing it for petabytes with big data analytics and all the compute engines that we are building on top of it, all the way from ingestion to transformation to warehousing. And it essentially has deep integrations with Power BI and Azure Machine Learning to give out powerful insights. The experience, and I think this is a very, very critical part, as you experience Synapse and the Synapse Studio, it becomes very, very obvious as to how simple we've made integrating multiple services or capabilities that exist today when it comes to things like common security, common deployment, common monitoring practices in a very, very no-code experience. And the unmatched security aspect of it, which is capabilities in individual services. When you think about all the work we've done around significantly expanding the capabilities of the SQL data warehouse, coupled with the work in Synapse in having a common security layer across the entire pipeline is going to make it significantly easier. Now, specifically focusing on price performance. So this is what you see on the slide is what GigaOM did in terms of comparing all the cloud data warehouses that exist in the industry today. And it's very clear, Azure Synapse, just hands down, was the best, really. And this, again, wasn't a surprise for us because of we essentially have taken the best of investments we've done with SQL Server over the last 25 years when it comes to distributed query processing, couple that with the investments that we are making in horizontally scaling out, doing the serverless model, building in security to support extremely high data volumes. Now, moving on to a little bit of detail in terms of how the sort of stack looks. Of course, Azure Data Lake Storage is really the one-stop shop or one place to land all your data inside Azure. In top of that, we basically support both a clustered form factor and a serverless form factor for both Apache Spark and SQL. So depending on whatever your familiarity is or whatever you're doing, whether it comes to data science, data engineering, or anything from a data professional standpoint, you should be able to do that. Like I mentioned, integration of the services, the manageability pieces in terms of how do you monitor it, how do you debug things when things go wrong, pinpoint the problems. All of that is very, very deeply integrated and in the whole Synapse Studio experience. A couple of things I'd like to point out. We're spending a lot of time deeply integrating Synapse with Power BI. So if you're a Power BI user, the big data system that you select or the warehousing system that you select, it's going to be a no-brainer. We started off with having Synapse Studio just build out Power BI report semantic models, and we really have some very, very big plans where if you run into scalability limits between Power BI and Synapse, how does the protocol work that automatically scales things up, pushes things down, so that the end user experience is always fantastic. And we're doing similar integrations with Azure Machine Learning when it comes to sort of tracking experiments, deploying machine learning models in a scaled out manner so your queries can include machine learning-based scoring. It's really great to see how this is all coming together. Another capability that I'm really excited to share today is the general availability of Azure Data Share. Sharing of data still continues to be a huge problem both within an enterprise and across enterprises in many cases, how business processes need to come together. And with Azure Data Share, we are basically making it really, really easy to share data with just a few simple clicks. It's not just secure, but you can essentially have very clear governance principles that you have around how you want to share the data. Whether you're allowing the data to be copied or you want in-place sharing, you just want a few queries to be run. It's just going to be super flexible. And there's also a whole notion of business model around it. There are a lot of customers we spoke to who want to monetize their data assets, but do that in a very secure and compliant way. And Azure Data Share essentially is opening up all these business possibilities for data that's there, that's stored in Azure. Now, please let me invite Paul Russell from Deutsche Bank, who's the head of engineering of the enterprise analytics platforms, to come and talk to us about how they're using Synapse and all the other capabilities that we have in Azure. Hi.
Hi, Rohan.
Thank you so much for coming over. So Paul, can you tell us a little bit about your current analytics environment, the capabilities, and the kind of challenges you're facing?
Yeah, like Microsoft, our position in Deutsche Bank is to provide a platform that empowers customers. We don't build too many end-to-end solutions. We are a player in many solutions across the bank for all the major divisions. How do we do that? We've built a multi-tenancy scalable platform around really core Hadoop. We've engineered Hadoop to work in a banking environment with the compliance and resilience that's required. We've added to that things like a data catalog, which supports discovery, data lifecycle management, and all the governance that's required in our environment. And we've also gone the next step to provide use case enablement for our customers by providing managed services for things like graph databases, machine learning toolkits, and other third-party capabilities. So our principle is basically to try and take the pain away from customers to get access to this amazing technology without having to deal with all the difficulties. So what are those difficulties? I think I'm sure people in the audience are familiar with Hadoop. A lot of different integration pain points. Most of the technologies by themselves work very well. Making them work well together can be a real challenge. Although we try to provide a private cloud experience and some elasticity, we can't really do that. If all our customers want more at the same time, that's a challenge. We can take advantage of some economy of scale, but that is limited, and we're back to procuring hardware for our on-premise environment, which has its lead times. And we have the noisy neighbor syndrome. We are in a shared multi-tenancy environment. We get some economies of scale from that, but also we get the pain of customers that are all wanting to run their load at the same time.
So thank you for sharing that. Can you share a little bit about how do you envision Azure Synapse and all the work that you're already doing with Azure's analytics services to help you?
Yeah, so our experience with Synapse has been really, really positive. We've been privileged to be invited into the private preview some months ago. We're working with Rohan's team. It's been a pretty good experience. We have it's a positive that's a really shared vision for what a data platform should be. The tight integration of the lake, the catalog, the analytics, and the security it's really good for us to see. I mean, we're trying to take that cost away from our organization. So to see that vision, we've been hands-on as well. So it's not just vision. We've seen and we're working with on-demand Spark and SQL Analytics. We are working with the product team around what's coming next, and we're really excited to be part of that journey.
Thank you so much for sharing your experience, and I hope you're super successful in Azure with Synapse.
No problem. Thank you.
Thank you. It's always fantastic when you have customers. Some of you may have seen Unilever in Jason's keynote, and Paul and Deutsche Bank. We have several of these large customers who are working with us in building out Synapse, and that's one of the reasons why right out of the gate we are so confident in the capabilities we've built out, the scale, the security, the unified experience and monitoring. One of the things that we sort of always get very excited about is the partner ecosystem that we've built around Azure and Azure Data Services, especially our analytics services. One of the partners that we're very, very excited about, it's a first-party service that we have in Azure called Azure Databricks. And please let me invite Arslan Tavakoli on stage, who's the SVP of Field Engineering and also happens to be one of the co-founders of the Databricks company. Hey, Arslan, thank you so much for coming over.
Appreciate it.
Do you want to first share a little bit about, the service has been on fire, so can you share a little bit about Azure Databricks and how you guys see it?
Yeah, to be honest, we're pretty humbled. I think it's been a little less than 2 years since you stood up here and talked about, Azure Databricks being in preview, and now we fast forward and you see thousands of customers using it. We process nearly 2 exabytes of data per month, and so to see that, you ask yourself what's led to that, right? And I think part of it is our partnership working together and understanding what customers really want to see. And I think a core is something really unique on Azure, this concept of a modern data warehouse pattern where you're able to say, how do we deliver an end-to-end solution that unifies what customers need? how do we bring together, the innovations of something like Azure SQL DW with some of the innovations in Azure Databricks, such as, Delta for reliable data lakes, Databricks runtime for delivering performance up to 50x over open source Spark, and ML Flow for orchestration, and combine this with the rest of the power of the Azure ecosystem. And I think one of the core parts as we've worked together is that deep integration, and that's why we're so excited about bringing those same set of innovations to integrate with the next generation of SQL DW and Azure Synapse.
So can you share a little bit about that? I mean, we've been, again, super excited about the partnership. I think it's sort of doing great. The modern data warehouse partner, like you said. So share a little bit of your thoughts that you have around our deep partnership, how that extends with Synapse.
Yeah, absolutely. I think if I go into all of them, they're going to yank me off the stage. So I'll just pick a couple from here. Three things come to mind. One is, we built this deep integration between the two services. We've been working together, which allows for fast data sharing. So that means you can leverage all of the benefits of basically Azure Synapse, and also leverage Azure Databricks, for example, for some of those workflows, as I mentioned, to drive basically up to 50x improvements open source Spark, leveraging the best of both worlds. There's a second one where we look at as Azure Data Factory gets pulled into the broader Azure Synapse ecosystem, being able to do that as another portal into being able to leverage Azure Databricks underneath. And then obviously there's the fact that now as we basically have this common substrate of basically ADLS underneath, of basically the two services being able to create basically an agility and a collaboration on the data and use cases that I think was unparalleled. And I have to say, honestly, I'm super excited to see what the next wave of 1,000 customers are going to do with the two services combined.
Well, thank you so much, Arsan, for coming over. It's
Thanks
fantastic
for having me, Rohan. Appreciate it.
Thank you. Well, so that sort of brings us to the end of the session. I hope that it gave you sort of some glimpse into the set of work that we're launching at Ignite and the excitement that we have around it. There are lots of deep dive sessions that I highly encourage you to go focus on. We have actually a whole session around SQL Server from edge to the cloud tomorrow. We're expecting a huge audience to show up, so please go attend that. And sessions for Cosmos DB, for Postgres Hyperscale, Synapse itself, Azure Arc, lots and lots of deep dive sessions for you. Hope you guys have a fantastic Ignite, and thank you so much.